All right, so we're going to talk about even and odd functions today. You are going to have homework over this, and you are going to have a quiz on Wednesday. So it's a pretty easy assignment. If you have any questions, make sure you come in to tutoring on Wednesday morning to get some help. And I'll take questions before the quiz, and it's review day, so I could take a couple more questions than maybe I'm usually taking since I'm not there today. All right, but you're watching this video, you're going to do your homework, and then if you have any questions on your homework, I'll either answer them before school, and if you're really totally lost, you need to come in the morning or go talk to Mr. Stahl because he could help you. So two things that we're going to talk about today are end behavior and average rate of change. So the behavior of the graph of a function for a very large value of x, either positive or negative, is commonly known as end behavior. And we're going to use, it says limit notation, and I meant to take that out, but we do need to use a specific kind of notation to describe the behavior. All right, so it's not technically limit notation, but it is with these weird arrows. So what this is saying here, this is the left side end behavior. And the reason why I know that it is left side end behavior is because of this little negative sign right there. So as x is approaching negative infinity, so the left side of your graph, f of x is approaching, this is the answer part. All right, so this is what you would be filling out. And then you have right side end behavior. So as x is approaching positive infinity, so that's how I know that we are approaching the right side of the graph, f of x is approaching, and then once again, this right here would be your answer part. And then I wrote in words like how you say it. So as x is approaching negative infinity, f of x is approaching blank. All right, so I have this chart down here, and I kind of made a mess up on this chart. This is supposed to say negative leading coefficient. All right, so that's supposed to say negative leading coefficient. All right, so if your graph is an even degree, which means the highest exponent is even with a positive leading coefficient, your end behavior is going to go up and up. So kind of think about a quadratic. If it's a positive leading coefficient, it would be like a happy face U, so your ends would go up and up. If it is even and a negative leading coefficient, it would be like a sad face U, and you would go down and down. All right, so if it's an even degree, your end behavior is the same. All right, so even degree is same end behavior. I'm going to abbreviate with the EB. All right, so if we're talking about odd degrees, so odd degrees are going to have different end behavior. All right, so think about a linear function. If you are an odd degree, but you're positive, the right side goes up, the left side goes down. So the left side's going to go down, the right side is going to go up. And then if you are odd degree and negative, right side goes down, left side goes up. So left side goes up, right side goes down. And I have a poster that I will put up that has this kind of chart there on the wall with the same kind of notation if you need a reference. All right, so on these examples right here, on example 60, we are just describing the end behavior. So just make sure that you are reading whether we are looking at the left or the right side. So this is the left side. The left side of my graph is going down. This is the right side. The right side of my graph is also going down. This next one here, left side's going up, right side's going up. So they're both going up. So up, up, so up to positive infinity. And then 62 is an odd one because they are going in different directions. So we do need to make doubly sure I put the correct number in the correct blank. So this is the left side because it's negative infinity. So the left side is going up. So I'm going to put positive infinity right here. This is the right side. The right side is going down. So I'm going to put negative infinity right there. All right, so let's look at these guys here where we don't have a graph. So once again, we're looking at the leading coefficient and the degree of the function. So I'm only going to care about one term. All I care about is this term right here. It is the biggest exponent, and I care about the leading coefficient. I don't care about anything else. So this guy here is even, and it is negative. All right, so even degree, negative leading coefficient, that is going to go down, down. So both of these are going to be going to negative infinity. All right, on this next one here, we are, once again, just looking at the biggest exponent. So all I care is about this x cubed guy. All right, so x cubed is the only one I care about. And so it is odd because 3 is odd, and it is positive because the leading coefficient is positive. So odd positive is going to go right side up, left side down. All right, so as we're approaching negative infinity, that's the left side. The left side is going down. As we're approaching positive infinity, that's the right side. The right side's going up. All right, on 65, we're gonna have to do a little bit of work on it. So I care about the biggest degree. So the biggest degree is gonna come from multiplying those guys together. So negative 1/2 x to the 4th is gonna be the term that's gonna tell me my end behavior. None of the other terms matter because just the biggest exponent term matters. So your exponent is a 4, so that's gonna be even. Your leading coefficient is negative. So that's going to go down, down. So left side's going to go down, right side's going to go down. All right, and then 66, last thing on end behavior here is I'm going to multiply these guys together. That's going to give me the biggest exponent. All right, so that those two terms multiplied together will give me the biggest exponent. So 3 times a negative is going to be negative 3. X squared times x cubed is going to be x to the 5th. So this is my leading term. It's going to be the term that has the biggest exponent. All these other exponents, they'll be smaller, so we don't need to worry about them. And so then this one here is odd and negative. So right side's going to go down, left side's going to go up. So left side up, right side down. All right, and that's how you're going to do end behavior. So last thing that we're going to look at is average rate of change, which should be pretty easy for y'all because it's something y'all did in Algebra 1. We're going to add some new vocabulary with it, though. All right, so a secant line, this is important. A secant line is a line joining 2 points on a function. Finding the slope of the secant line through 2 points will give you the average rate of change. So this vocabulary here is just to prepare you for if or when you're going to take calculus, right? It's the same process that you've done in Algebra 1, but we're just kind of adding some fancy words to it. So if you look over here at my example, this guy right here is a secant line. It is the average rate of change through point C and through point X. And so we have a bunch of formulas that represent the rate of change or slope. Okay, so average rate of change, same thing as slope. All right, average rate of change, that's what AROC stands for. Same thing as slope of the secant line. That's why it's MSEC, it's the secant line. Also the same thing as change of y over change of x, which you probably recognize this formula, y2 minus y1 over x2 minus x1. Or if we're talking about function notation, f of x, which is the same thing as y2, minus f of c, which is y1, and this is x1 and x2. Or x2, x1, my bad. x2, x1. All right, so same thing, just written in function notation. All right, so there's lots of function notation there on that. So try not to get overwhelmed with that. All right, example 67, it says find the average rate of change over the given interval and sketch the line on the graph. All right, so on this one here, we are sketching -2, which is this point right here. So y1 is going to be -2. And x2 is going to be -1, which is going to be up here. So then y2 is going to be 2. So to sketch the secant line, this is the slope that I'm finding. all right, which you could do rise over run if you wanted to. We're also going to plug it into the formula. So y's are on top, change of y on top. So 2 minus negative 2 over negative 1 minus negative 2. Double negative turns those positive, and so then you get 4 over 1, which is just 4. So your average rate of change, or the slope of the secant line, is just 4. All right, so this next example here, we've got one of my x's at 0, which means y1 is going to be 0, and my other x at 1, which means y2 is going to be negative 2. All right, so my slope of my secant line looks something like that, kind of. All right, it's the line going through those 2 points. So if we're trying to find the average rate of change, which is the same thing as slope, we're going to do y2 minus y1 over x2 minus x1, which gives you negative 2 over 1, which is the same thing as negative 2. All right. On this last page here, example 69 says find the average rate of change, and it gives me the equation and an interval. So on this one, we have to find the y values. All right, so we have my two x values, 3 minus 1, but we need to figure out the y values. All right, so f of 1, we're going to plug 1 in. 1 cubed minus 3 times 1, so 1 minus 3, which is, oh, yep. All right, sorry, 1 minus 3, which is negative 2. All right, so that needs to go, make sure they line up. It doesn't matter which one goes first, but it does matter if they don't line up. So we plus plugged in f of 1. So negative 2 is your y2. I'm going to put it in above the 1, if that makes sense. Maybe I should have color coordinated. All right, so f of 1. All right, so now I'm going to do f of 3. So 3 cubed minus 3 times 3. 3 cubed is 27 minus 9, which is 18. So that one has to go here. So 18 minus. All right, so f of 3, 3, and that's where I got 18. And so 18 needed to go right there. All right, and so then double negative, that's going to turn positive. And so then you get 20 divided by 2, which is 10. So your average rate of change is 10. All right, example 70 here is like putting it all together. So kind of is combining like a lot of the things that we've talked about. We have these two graphs here. I'm going to kind of color coordinate so it's easy to see. I've got G right here. And I'll do the other one in blue. Oh, wait, no, I'll use purple. All right, so these are my two graphs. So it's wanting the domain of f and the domain of g. Well, if you look at your two graphs, both of them are arrows going forever in both directions. So your domain for both of these guys are all real numbers or negative infinity to infinity. All right, they both have arrows extending forever. All right, now I want the values such that f of x, which is the purple one I have, equals 0. So those are the x-intercepts. So I have just 9. X equals negative 9. It only is crossing the x-axis right there. When g is 0, that's crossing a couple different times. It's crossing at negative 6 and negative 2. Now it does look like it's going to go down here and it's going to cross somewhere over here, but we don't know. So you can't assume anything. You can only assume what's happening on the graph as of right now. All right, so values such that f of x equals g of x. So that's going to be where they intersect. All right, so they intersect at those 3 spots right here, here, and here. So this guy here is at negative 8. This guy here is pretty close to 1. And this guy here is at 7. All right, now we're going to do the values where f of x is greater than g of x. So remember, f of x is my purple one. So when my purple one is on top, so when my purple one is bigger, that's going to go from negative 8, and it's on top all the way to 1. And then it goes on bottom, And then it's going to be on top again from 7 to infinity. All right, next one. Find the values when it's on bottom, when it's less than g of x. So it's less than from negative infinity all the way to -8. So this area right here, and it's less from here to here. So that's going to be 1 to 7. All right, now we're finding the values where g of x is greater than 1. So that's going to be above the x-axis. That's what it's talking about. Oops. All right, so the parts on this graph that are above the x-axis for g, which is the maroon colored one. So we're above the x-axis from negative infinity to -6. And then from -2 to infinity. Because remember, we are just going to assume that this is going to go, and we can't really, we don't know what's happening. All we know is that there's an arrow there, so we're assuming we're above the x-axis. All right, so we're going to do the same thing now, but for f of x. But it's less than. So we're going to say, when is f of x below the x-axis? All right, below the x-axis. So that is going to be negative infinity to -9. So from here to here. All right, find the values of x such that f of x is increasing. So now we're looking for increasing intervals. All right, so f of x, which is my purple one, so we are starting off increasing because we're going up. So we're increasing from negative infinity all the way to the top right here at this maximum, -7. Then we decrease, and then we're going to increase again from -4 all the way to the top to this maximum, which is at 0. Then we're going to decrease again, and then we're going to increase from 4 all the way to this top, which is infinity. All right, I find the values when you're a constant. Constant is pretty easy. You're looking for the flat line. So the only flat line is from here to here on G. So that's going to be -1 to 3. And then you're going to have, when is G decreasing? So once again, G is the maroon one, and we start off decreasing. So we are going to decrease all the way. So we're decreasing here. Now this guy here, we're still decreasing. It's just at a different rate. But this whole time, we're decreasing all the way to the minimum, -4. Then you're going to increase, then you're constant, and then you're going to decrease again from 3 to infinity. So careful on the change of decreasing. You're still decreasing, so you don't need to stop. All right, almost done. The values when f of x is greater than 0. So now we're talking about when f is above the x-axis. All right, so f is the purple one. So we are above the x-axis from -9. We are above the whole time to infinity. And now it wants me to do when f is decreasing. So f is the purple guy. And so we are increasing, and then we're going to decrease. So we're going to decrease from -7 to -4. And then we're going to increase, and then we're going to decrease from 0 to 4, and then we're going to assume that we are increasing again forever and ever. All right, so that is it for the notes, and that's it for the first unit that we're doing in pre-cal. So for the rest of class, work on your homework. You can work together if you want. You do have a quiz. Now, I will say your quiz, you're going to have an average rate of change, and you're going to have an end behavior. Make sure you know how to do this notation, and you can always reference the poster that is going to be on the wall. So you'll have a question like this on your test that kind of combines a lot of the things that we've done for this unit as far as the attributes of the functions, but this won't be on your homework quiz. So if you're a little stuck on this, it's not a big deal for your homework quiz. You just need to make sure you're ready for your test. Your homework quiz is going to be an end behavior and an average rate of change. So once again, if you have any questions, I'll be here in the morning, and you also can ask Mr. Stahl because he can help you with any of this as well, or any of the math teachers really. I will see you tomorrow.